Do you want to know why O of 1 is good? Well, in this video, I will teach you everything you need to know about O of 1. My name is Anjan. I am a full stack web developer. I write blog posts at medium.com and dev.to. I also run this YouTube channel where I teach full stack web development, data structure algorithms, and many more. So hit the subscribe button so that, my friend, you don't miss any of this cool stuff. In the previous video, we have talked about what is algorithm, why do we need algorithm complexity, what is good code, what is algorithm complexity, big O notation, and so on. In this video, we will learn what is O of 1, complexity, how to recognize it, why it is good, and some examples. So, if you have no idea what is algorithm complexity or big O notations, please watch the previous video that I've created. I will put the link on the description. Grab the basic idea of algorithm complexity, then come back to this video. So what is O of 1? Let's take a look at one example. Write a function that will take an array of numbers as an input. The function will increment the first 5 elements of the array. Then the function will return the array. So this is the solution. This function takes an array of numbers as input, and inside the function this traditional loop, and then after the loop this function is just returning the array. This is an array size of 10, and I'm calling this function, passing this array as an argument. Let's take a look what is happening inside this function. This is just a normal loop where I is assigned to 0 and I will run until it is equal or greater than 5. That means after each iteration or after each loop, I will be incremented by 1. And inside the loop, we are just getting the value of ith index of the array and incrementing the value, and then assigning the incremented value to the ith index. After the loop, this function is just returning the array. So what is the algorithm complexity of this function or this algorithm? Let's count how many times this loop is running. Inside the loop, we are taking only one step. We are just getting the ith index value, then we are incrementing the value and assigning to that index again. So this is only one step. But how many times this one step will occur? 5 times. Why? Because I will run until it is greater or equal to 5. So the last time the loop will run when the I will be equal to 4. After that loop, the I will be equal to 5. The loop won't run again. So 0 to 4 is 5. 0, 1, 2, 3, 4. That's obvious. So this iteration will happen 5 times. On each loop or each iteration, this operation will happen. So we can say that the number of steps will be 5 into 1 plus 5. I hope you are getting it right. So this is the same function again. Just assume that this array size is now 1 million. Then what will happen? How many times it will run? So we are just we are incrementing and assigning the value one time. Then how many times this loop will run? Again 5 times, because it will only increment the first 5 elements of this array. It won't go further. So again 0 to 4, 5 times. Can you see any similar pattern going on between these two examples? Yes, they both are taking only 5 steps. It doesn't matter what the input size is. If it's 10 or million, the number of steps always stays the same. So what can we call this growth? We call this constant time growth. Now what is constant? Constant is the number that never changes. If you are a programmer, then you should know what a constant is. Both this algorithm does not care about the input size. If it's 10 or million, it will always take the same amount of steps. So it does not care about the input size. It will always take the same amount of steps. This is what we call O of 1 complexity, where 1 is just a constant here. 1 cannot change. You cannot change 1 to 2 or 2 to 3. You cannot change a number. So why O of 1 is good? It doesn't slow us down when we scale our program. We know that a scalable code is a good code. We have to scale our program, and when we have to scale our program, we don't want much difference on the algorithm. We want our algorithm to take less amount of steps as possible. So when we scale our program to 10 to 1 million, our program is always taking the same amount of steps. It's not growing or it's not decreasing. It is stable. It is consistent. So it will stay fast. If it was growing like from 5 to 50, the number of steps, then it would be slow. But it is not slowing. It is staying consistent. Let's see a graph. This is a graph from biggocheatsheet.com. I will put the link on the description. So this horizontal axis is the number of elements or the size of the input, or this vertical axis is the number of operations or the number of steps. So these are the lines of complexities. So as these lines go higher, the more horrible it becomes. The more these lines are laying down and closer to the horizontal axis, the more it is good. You cannot see the O of 1 line because it has been merged. Let me demonstrate. So I have created this stupid graph. If it's 20, we are still taking 5 steps. If it's 100, we are still taking 5 steps. If it's 1 million, we are still taking 5 steps. Like our previous example. It is not growing, so this line won't go up. It will always stay consistent and it will go horizontally straight. So because it won't go up, that means it won't take many steps. So it will stay good. This line won't go up. That's why it will stay fast. Like this graph describes that the more up it goes, the more up this line goes, the more horrible it becomes. The more close it stays to the horizontal axis, the more excellent or good it is. So just because this O of 1 is a horizontal straight line, that's why it has been merged with this axis line. So O of 1 is good. This is a complexity growth of algorithm. I got it from a Stanford lecture. I will put the link on the description. This table shows how the number of steps grows as we scale our program. Let's focus on this O of 1 class. So n is now 10. That means the input size is 10. We're taking 1 step. If it's 100, 1. 1000, 1. Even if it's million, we are still taking only 1 step. So we can say that it is consistent. The number of steps is not growing as we scale our program. So O of 1 is good because the number of steps will not grow when we scale our program. But the number of steps wasn't 1 actually. It was 5 in my example. But why say 1? Why say O of 1? Because of simplicity and standard. Different algorithms might take different amount of steps. Some algorithm might take 10 steps, some take 20 or maybe 2 steps. It varies on algorithm implementation. So it doesn't matter which algorithm you use or how many steps it's taking. It is the growth matters. And end of the day, if we simplify this O of 1, we get just 1 because 1 is just a constant. It never changes, and this is a constant time growth. You cannot change 1 to 2 or 2 to 3. Okay? And I will make a video about how you can simplify these big O notations in standard way. So hit the subscribe button to stay updated. So in the next video, we will talk about O of n. So thank you for watching. If you have any question, feel free to comment down below and I will try to answer them all. If this video has been helpful for you, don't forget to like, share and subscribe, and I'll see you later.